And here we are getting ready to stack cables in a wise manner with StackWise. StackWise gives us the ability to physically link up to 9 switches. And what we're doing is creating a switch unit, or the more common term really is switch stack. Now we can't do this with good old patch cables or crossover cables or console cables or anything you probably have in your network kit right now. We have to get some stack interconnect cables. But what we end up with is a fully functioning bidirectional path, a two-way path, and each path supports up to 16 gig, and that's in each direction. So we're looking at 32 gig overall of capacity. That's pretty darn good. Now we have multiple switches, so we know one of them has to be the boss, and that is the aptly named master switch. And to go with that, we have a master switch election, and I want you to know how that election is carried out. First off, you and I, as the network admins, we do have the option to select a particular switch to be the master, which is great. But if we don't care, if we have 9 switches of the exact same capacity, maybe we don't care, then we need some criteria to make that election happen. And next, the switch with the best feature set, the feature set with the most features, if you will become the master. If that's a tie, probably is, a switch that's been pre-configured wins over switches that have not been pre-configured. And that is correct. I know you read that, it's like, what do you mean pre-configured? We're going to hit that in a few minutes here. If that's a tie, the switch that's been up the longest wins. Fair enough. If there's somehow a tie there, you know the MAC address has to get involved in any process, any selection process, right? If they all have the same feature set, if they've all been pre-configured or not pre-configured, and you have a tie as to who's been up the longest, finally the switch with the lowest MAC is selected as the master. This is an important decision because the master switch has quite a workload. It's going to download forwarding tables to the non-masters. It's going to send ACL and QoS information to the non-masters. When a switch is removed or added, the master switch lets all the other switches know about it. The master switch keeps a master MAC address table, sends that to all the non-master switches. And when you and I ping or telnet to that stack, it's the master that's actually handling it. That's the physical switch that we are actually hitting. So there's a lot going on with that master switch. The entire stack has one IP address and one configuration file. And that config file, a copy of that is given to every switch in the stack. Now what we love about this, you and I as in that network admin role, we can add and remove switches without interrupting the service. You don't even have to configure the switch you're going to add. I'm not kidding. StackWise is going to take care of that for us. And the stack's master switch is going to auto-config the new arrival with the stack's iOS image. We will talk more about that and how that happens in just a moment. Now, there is no single point of failure in a switch stack, but there is a single point of pain. If one of our cables breaks, we take a 50% hit in capacity. Wham! That's not good. But what is good is that the failover, the repair, if you will, takes literally microseconds. So that 50% cut in service we're looking at, very temporary. Also, NSF comes into play, nonstop forwarding. That helps keep the packets flowing when there's even a slight break in service, such as when the master switch goes down and another one has to be chosen. In StackWise, NSF works with RPR Plus to keep things rolling when we're cutting over from one master to another. The non-master switches are fully initialized and they're ready to step in at a moment's notice. It's still pretty quick. It's not as fast as SSO, but it's still pretty quick. Now, let's talk about image. Because with StackWise, the iOS image is indeed everything. StackWise requires that every switch in the stack is running the same iOS. It's also recommended heavily that stack members have the same feature set, either IP services or IP base. Now, I mentioned you don't have to configure a switch to add it to a stack. And of course, our ears go up at that. It's like, really? The switch is going to automatically configure itself? Well, not really. The master switch is going to do that for us. Because when we add that switch, what the master does, it asks the newcomer, are you running the same iOS image as I am? Well, if everything is fine there, then the master just sends the config file to the new switch and things move forward. Now, if the switch doesn't have the same iOS image, this path is followed. First off, the master is going to download the iOS from its own flash to the new switch, send the config to the new switch joins the stack, everything is beautiful. Now the second one, we have the option of configuring a TFTP server for that iOS download. That should sound familiar. And if we do that, the master switch grabs the iOS image from the TFTP server, sends it to the new switch, sends the config over, and the switch joins the stack successfully. Now those first two possibilities assume the new switch's hardware can handle the iOS image in question. Now if that is not the case, and I will change that one word there, if that's not the case, the master will put the new switch into suspension and then let us know about the problem and then wait for you and I to do something about it. And in this case, the do something about it part, we actually have to do some work here. The master expects to be supplied with an iOS image that supports the master's hardware as well as the new switch's hardware. Now once that happens, the master then upgrades every switch that was already part of the stack to that iOS along with the new switch, and then finally the entire stack goes live. So there's a lot going on there at the end, and we really hope it's either number one or number two, and we hope our hardware is compatible, but if not, we can take care of that. This is more than enough to get you started with StackWise. Gives you the fundamentals, and as you'd expect, there is a lot more to this feature. As I mentioned in the VSS video, Cisco could just have a certification on VSS and StackWise and StackWise Plus. There are several excellent white paper PDFs on Cisco.com regarding StackWise. They're not required reading for your switch exam, but if your network uses it or you just want to learn more, which is always a great option, head on out there, because right now on the next video, we're going to start with our first hop redundancy protocols, starting with, I believe, HSRP. See you on the next video.